In this class, we will show you how to use VLANs and FortiGate virtual domains. VLANs and VDOMs are not directly related. Multiple VLANs, for example, do not define a VDOM. However, they are both in this class. They are often used together if you route traffic from multiple companies or divisions through the same FortiGate. For example, if you're a large university, you may want to assign a network administrator for the accounting department to configure the firewall policies governing that department, but not allow them to affect other departments. Relatedly, you may want all accounting offices to be on the same virtual LAN, even though they are located in physically separate buildings. Here's an overview of what we will discuss. Essentially, we will talk about two methods that you can use to separate and join traffic into logical domains that might be handled by separate administrators, for example, or separate security policies. We will also discuss how to route traffic between two of these logical domains. Note the capital letter V because we're not talking about VLAN adapters on virtualized machines such as VMware or Xen. VLANs are created when we configure a network interface that corresponds to a physical NIC port such as port 1 or port 2 to subdivide traffic based upon tags found in the Ethernet frame. When we do this, the frame has more than just a MAC address that we can use to map to an IP subnet. Let's see the difference. Above shows a plain Ethernet frame. It contains MAC addresses for the physical adapters that are sending and receiving the frame, the type, the data payload that in this case will contain the IP layer, and finally a CRC code that helps to ensure noise hasn't corrupted the frame data. The diagram below shows an Ethernet frame that complies with the 802.11q VLAN standard. Notice that it has 4 more bytes in the middle. In the diagram before, we showed that VLANs add 4 bytes to each frame. What are they used for? They have an identifying number. Regardless of which physical port transmitted or received the frame, if the frame has the same VLAN ID tag as another, it can be organized into the same virtual LAN. FortiGates can add and act on this ID. Notice that VLAN IDs are not authenticated nor encrypted. Their original design was to improve LAN performance by providing a way to prevent unnecessary frame retransmission. Many people think that VLANs are a security measure, but the VLAN standard provides no mechanism to guarantee that the ID has not been maliciously altered and shouldn't be inherently trusted. To guard against VLAN spoofing, physically secure switches and routers. Also consider features such as reverse path forwarding. Strictly speaking, VLANs aren't secure on their own. They simply define logical LANs. When operating in NAT route mode, FortiGate is, among other things, a Layer 3 router. So it can do more than a Layer 2 switch. That is, it doesn't just remove VLAN tags from frames being forwarded to destinations and add VLAN tag frames being forwarded from the source. FortiGate can also rewrite VLAN tags. Before FortiGate forwards a frame, if you've configured it, FortiGate will change the VLAN tag. This allows it to arrive at a destination that belongs to a separate VLAN. In contrast, if FortiGates were only a VLAN switch, it would not forward it to any other VLANs. The packet would be dropped. In the example above, a computer sends a frame which passes through a router first. This router applies a VLAN 100 tag since the frame originated from a computer on VLAN 100, not VLAN 200. Then, the router forwards to the network interface on the FortiGate that is also configured as part of VLAN 100. Then, the FortiGate is configured to route from VLAN 100 to VLAN 300. FortiGate removes the VLAN 100 tag and matches the packet with a firewall policy. Since the packet is acceptable and is destined for an address on VLAN 300, FortiGate rewrites the VLAN ID to VLAN 300 before forwarding it to the next router. The last router removes the VLAN tag because this is the last hop, then forwards the frame to its final destination. Note that all devices on your VLAN pass must support VLANs. When configuring FortiGate, the VLAN tag in the frame will be exactly what you configure. On other vendors' devices, this may differ. In this example, computers located in separate buildings are part of the same department, accounting. They often share files, which results in much traffic. But notice the other computers in each subnet. They are not part of accounting. They are connected to the same switch only because they are located in the same room, not because they are logically related. They shouldn't be bombarded with frames from accounting computers. To prevent broadcast collisions with neighbors, we would connect network cables from each of these three accounting computers to their own switches in order to create a distinct physical LAN. Instead, the network administrator here has configured FortiGate and other devices to VLAN tag the frames from accounting computers. This causes frames to be forwarded only to devices in the same VLAN. To route a packet to another VLAN, the frame must reach a Layer 3 router, such as FortiGate, which can rewrite the VLAN tag. So far, we've seen network segments subdivided and unified. It was one organization with a single set of policies and a few administrators. In effect, a single security domain. What if you are an MSSP? What if you are a very large company? What if you want to subdivide policies and administrators into multiple security domains? In that case, you can enable FortiGate VDOMs. Each VDOM has its own interfaces, which can be real or virtual. It also has its own routing tables, firewall policies, packet inspection, and so forth. In that way, enabling VDOMs causes your FortiGates to behave as if they were multiple smaller FortiGates. Due to hardware differences, the maximum number of VDOMs varies by model. For models with greater hardware capacity, you can purchase a license to allow more VDOMs. Configure this with care. Due to shared hardware, the total number of sessions, etc., for all VDOMs will impact performance. Next, let's see how you can fine-tune VDOM resource allocation. Remember, VDOMs are a logical separation only. Each VDOM shares physical resources with the others. Unlike with FortiGate VM, VDOMs are not allocated and balanced with weighted vCPU cores, VRAM, and other virtualized hardware. To fine-tune performance, you will configure resource limits for each feature, IPsec tunnels, address objects, etc., at both the global level and for each VDOM. This controls the ratio of each VDOM's system resource usage to the total available resources. For example, on this FortiGate, the hardware is powerful enough to handle up to 2,000 IPsec VPN tunnels. The FortiGate is configured with 3 VDOMs. VDOM 1 and 2 don't use IPsec VPN tunnels often and are allowed to have up to 50 each. VDOM 3, however, uses VPN extensively. Therefore, this FortiGate will be configured to allow VDOM 3 to have up to 1900 tunnels. Additionally, 1,000 of these tunnels will be guaranteed. Configure your FortiGate with total limits for critical features such as sessions, policies, and others. Then configure each VDOM with its own quotas and minimums within the global limits. Global resource limits are an example of global settings. The firmware on your FortiGate and some settings, such as system time, apply to the entire appliance. They are not specific to each VDOM. Most settings, however, can be configured to be different for each VDOM. To enable VDOMs when you are logged into the GUI, in the System Information widget on the dashboard, in the Virtual Domain row, click the Enable link. This won't reboot your FortiGate, but it will log you out. Enabling VDOMs restructures both the GUI and CLI, which you will see when you log in again. Alternatively, to enable VDOMs when you are logged into the CLI, enter this command. Again, you'll see the new structure of the CLI and GUI when starting your next administrative session. After enabling VDOMs, by default, only one VDOM exists, the root VDOM. It's the management VDOM, which we will discuss soon. You need to add a VDOM for each of your security domains. If you're an MSSP, for example, you might add one VDOM per client company. If you're an enterprise business, you might add one VDOM for each division of your company. Remember that, as described before, you also may need to adjust each VDOM's resource allocation. If you log in as most administrator accounts, you will enter your VDOM automatically. But if you were logged in as the account named admin, you aren't assigned to any VDOM. To enter a VDOM on the GUI, click the Virtual Domains part of the menu. Inside, you will see the default VDOM named root. This is the management VDOM, which we will see more of soon. Other VDOMs that you can configure will also appear under the Virtual Domains menu. To access a VDOM, click it and expand its contents. Inside each VDOM, the submenu should be familiar. It is essentially the same navigation menu that you had before you enabled VDOMs, except that the global settings moved out to the global part of the menu. Access to VDOMs isn't the only change to the GUI and CLI. How does enabling VDOMs change the structure? Settings that apply to the entire FortiGate are split apart from settings that can be configured individually for each VDOM. Administrator privileges also change. For example, by default, while VDOMs are enabled, some CLI commands are available only to the admin account while within the config global shell. The admin account is the only account that isn't assigned to a specific VDOM, and so it is the only one that should be able to configure global settings. Note that you can grant access to multiple VDOMs if you assign. Other CLI commands are available to any administrator, but only from within a subshell such as config VDOM, edit VDOM 1, because they are specific to that VDOM. The same permissions that apply to the GUI and CLI also apply to backups. We'll talk more about VDOM administrators in a minute. For now, let's see how you enter a VDOM. In most cases, you'll start by creating one administrator account per VDOM. He or she will be chiefly responsible for that VDOM, including that VDOM's configuration backups. In larger organizations, you may need to make more VDOM administrators. Multiple administrators can be assigned to each VDOM. You can subdivide their permissions using access profiles in order to follow best practices for segregation of duties. The converse is also possible. If required, you can assign an administrator to multiple VDOMs. If you want to grant access to all VDOMs and global settings, select SuperAdmin as the access profile when configuring the administrator account. Similar to the account name admin, this account will be able to configure all VDOMs. Best practice dictates that you usually should avoid unnecessary security holes, however. Do not provide SuperAdmin access if possible. Instead, restrict each administrator to their relevant domain. That way, they cannot accidentally or maliciously impact other VDOMs, and any change or mistake will be limited in scope. Similar to when you create new VDOMs, when you create new administrator accounts and assign them to a VDOM, access it through the global part of the navigation menu. To review, each VDOM behaves as it is on a separate FortiGate appliance. With separate FortiGates, you would normally connect a network cable and configure routing and policies between them. But VDOMs are on the same FortiGate, so how should you route traffic between them? The solution is inter-VDOM links. With inter-VDOM links, you won't send traffic out through a physical cable or VLAN, then back into the same FortiGate to reach another VDOM. Inter-VDOM links are a type of virtual interface. Note that, like with inter-VLAN routing, Layer 3 must be involved. You cannot create an inter-VDOM link between Layer 2 transparent mode VDOMs. At least one of the VDOMs must be operating in NAT mode. This means its network interfaces will have an IP address. Destination addresses and gateway IPs are required by routing with the IP protocol. It also prevents potential Layer 2 loops. When creating inter-VDOM links, you'll need to create the virtual interface, but you also must create a matching firewall policy, just as you would if the traffic was arriving on a network cable. Otherwise, FortiGate will block the traffic. In the menu, creating a network interface is located in the global settings. To create the virtual interface, click the drop-down menu arrow, then choose VDOM link. Up until now, we've discussed traffic passing through FortiGate from one VLAN or VDOM to another. What about traffic originating from your FortiGate itself or destined for it? Administrator sessions and system daemons such as NTP and FortiGuard updates generate this kind of traffic. When VDOMs are enabled, this means that a special VDOM named root must be automatically created so that the FortiGate has network interfaces that can continue to send and receive system-related packets. Similar to a FortiGate without VDOMs, the root VDOM usually should have outgoing internet access. Otherwise, features such as scheduled FortiGuard updates will fail. There are a few ways you can arrange your VDOMs. In this topology, each network accesses the internet through its own VDOM. Note that inter-VDOM traffic is not possible unless it physically leaves the FortiGate towards the internet and is rerouted back. This is most suitable for multiple customers sharing a single FortiGate, each in their own VDOM with physically separate ISPs or large pipes, for example. Notice that there were no inter-VDOM links in the previous example. Traffic flowed to the internet through completely separate physical links. This is another example. Like the previous topology, each network sends traffic through its VDOM, but after that, traffic is routed through the management VDOM, by default named route. So internet-bound traffic flows through a single pipe in the route VDOM, and if route VDOM policies allow it, inter-VDOM traffic is not required to physically leave the FortiGate. This could be suitable for multiple customers sharing a single FortiGate, each in their own VDOM. But in this case, the management VDOM could log and monitor traffic and/or provide standard services like antivirus scanning. Since traffic would not be scanned twice, one during egress, the second during ingress, in some cases it could improve performance compared to the previous example topology. Note that this topology has inter-VDOM links, but peer VDOMs are only linked with the management VDOM, not with each other. In this case, VDOM's traffic flows through the same physical link, the one belonging to the management VDOM. Inspection could be done by either the root or original VDOM, depending on your requirements. Alternatively, you could split inspection so that some scans occur while traffic is in the root VDOM, ensuring a common security baseline, while more intensive VDOM-specific scans can optionally occur in the originating or destination VDOM. Here, traffic again flows through a single pipe in the root VDOM towards the Internet. Traffic between VDOMs doesn't need to leave the FortiGate. However, it also doesn't need to flow through the management VDOM either. Inter-VDOM links between peer VDOMs allow more direct communication. Like the previous example, inspection could be done by either the root or original VDOM, depending on your requirements. Due to the number of inter-VDOM links, this example is the most complex, requiring the most routes and firewall policies. Troubleshooting meshed VDOMs can be more time-consuming. However, meshed VDOMs also provide the most flexibility. For large businesses, inter-VDOM communication may also be required, and inter-VDOM traffic performance may be better due to a shorter processing path which bypasses the management VDOM. Now it's time for the labs. In this lab, you'll enable VDOMs, then create a VDOM and assign administrators to it. You'll also route traffic through your new VDOM.